أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Recently, I've been asked repeatedly how to solve discriminant validity issues. Although there are videos available on the channel and that solve or try to solve the discriminant validity issues. However, at times the issue still persists. Now, in order to solve this issue or further investigate what could help solve a discriminant validity issue, we can use a standard deviation function. Now, let's say I've got this model here. Let's run this model, PLS algorithm, all checks out, start, discriminant validity, HTMT, and look at this here. This is quite high, 0.921, 0.926, 0.934. Now, how do we solve this particular issue here of significantly high discriminant validity? Now, even if we look at the cross-loading, sometimes we find out that the difference is greater than 0.10. Although removing the item may help sometimes, but at times it does not help. Now, in order to solve this issue, what we can do is we can go back to our data and find out if the respondents actually filled in the data correctly. Now, if there is very low or no standard deviation, this means that the respondents actually did not take or did not pay attention while filling in the data, and they just marked their responses. Now, how do we check that? Now, look at this. The problem is with this LG variable here and HC. LG and RC, HC and SC. So the problem is actually with 4 constructs. LG, HC, RC and SC. 1, 2, 3 and then LG as well. Now what I'll do is I'll check whether there is any kind of standard deviation than the required limit, which we already discussed in one of the previous session, that it should be greater than 0.25. So let's have a look here. So here is the data, and let's add is equal to standard deviation dot p, and the constructs were LG, and it wasn't FP, it was these 3 as well. Now let's press enter. Now just press this sign and the formula is replicated onto all the other rows in the data. Now let's sort it. Smallest to largest. Expand the selection, yes. And look at this. There is no standard deviation. Look at this, 1, 1, 1, 1, 1, 1, 5, 5, 5. So there is no standard deviation. They just marked their responses. These are not true responses. They need to be deleted. Now furthermore, you can first delete them, and then since the required limit as we assessed is greater than 0.25, so let's delete it up until here. The 51 responses may be deleted here. Now this is the reason, obviously it is suggested to have a higher sample size. So let's do it, delete. Let's save it. And let's have a screenshot of this as well, so that we can compare both of them. Let's copy it. Let me put it here. Now this was the original one. Now let's save it and let's import it as well. Again, right click, import data file, choose, press OK, and let's say I name it 1. Okay. Now what is the issue? Again, let's rename it standard deviation, save it, import it again. Now here it is, and the responses are 267. Previously they were 318. Now let's run the model again. Let's go to PLS algorithm, Start calculation. And let's have a look at our HTMT. Now look at this. It decreased significantly. Let's compare it with the original data, or rather the previous one. Let's put it here, Control V, and look at this. Now it's significantly reduced. Now it's very close to 0.90, which is a liberal approach to HTMT. Now you can further look at the cross loadings now and maybe delete a few items that are loading higher onto other construct instead of the underlying construct. Obviously there is a video on this as well, so I'm not going into detail as to how to do cross loadings or delete items based on cross loadings. Let's do one actually, HC and SC. So where is HC? Here is your HC. And now let's compare it HC with SC. So this is fine, the difference is greater than 0.10, although it is loading very well onto the other factor. Now all of them I've got higher difference. Not much of an issue. And let's look at the other one, LG and RC. So this is your LG and RC. This is here, this is fine, this is fine, this is fine as well. So all the differences are greater than 0.10. But again, what we can do is we can run bootstrapping and check bootstrapped HTMT results. For now, just 500 for the sake of the video. Let's start. Now let's look at bootstrapped HTMT. Here it is, and was corrected. Now look at this, 0.909, 0.906. Is there a 1 in between? No. So we can say yes, it is, or the discriminant validity is established. So using the standard deviation method, you can solve your discriminant validity issues as well. And further, you can look into the other methods that have been discussed on the channel. The videos will be shared in the description. Thank you very much.